Hello. Hello. Are you able to hear me speak?
Yes, I can hear you.
Okay. Yeah. Yeah. Good afternoon.
Hello.
My name is Austin, and this is about forensic chemistry.
Ooh, okay.
And I can share my screen. Um, right.
So, actually, I'm not interested in forensics. It's okay.
What did you say?
I'm not interested in forensics. I thought it was organic chemistry,
Oh,
but
this is forensic. Okay. Okay.
I'm sorry.
Okay. No problem.
I take your. Thank you.
What did you say? Hello. Hey, how you doing? Good afternoon.
Good afternoon. How are you, Sam?
Good afternoon.
I was just going through the Zooms. Is it over? Oh,
What?
like there was a list of like topics, and then I just joined this. Is it all like you're done?
Oh no, no. Would you like to hear about it?
Yeah, sure. Yeah.
Okay, okay. Let me share my screen.
All right.
Okay, are you able to see this?
Yes.
Okay. This project is it's all about finding out how much alcohol is in hand sanitizers. So we used gas chromatography, and first we made like a mixture of methanol, ethanol, isopropanol, and N-propanol, and then we analyzed it in the GC, and this was the output. And methanol is right here, number 2, and ethanol is 3, isopropanol is 4, and N-propanol is 5. And this shows how the GC can separate the alcohols. So it shows that there are 5 different, well, peak 1 is oxygen, but it shows that in the sample that we made, there are 4 different alcohols. And then to test it out on hand sanitizer, we tried it with methanol and ethanol, and we tried an internal standard methanol and an internal standard ethanol. So basically, the internal standard is the red peak for methanol, and for ethanol, it's this one. And the regular ethanol is the blue peak, and the regular methanol is this blue peak. So overall, we tested 4 hand sanitizers, and we found that they all contained the amount of ethanol that was claimed on the label, except for one of them. One of them was claimed to have no ethanol. And we did find a very small amount of ethanol. We found 0.8% ethanol. But the active ingredient was not ethanol. It was benzalkonium chloride. And yeah, so we found that ethanol is not always used in hand sanitizer. In this case, it was benzalkonium chloride. Do you have any questions about this poster that you would like to ask me?
It looks really good, but do you have like the name of the brand for the hand sanitizers? Like
I do not have that information right now.
yeah. Yeah, like I always saw like hand sanitizers they're gonna have like ethanol or like some type of alcohol. Yeah, but yeah, the poster really looks good. I don't have
Thank
much
you, thank you.
questions.
Yeah, so really the whole point was just basically just to study about figuring out if what the label claims is true. That's
Oh yeah.
basically what it was all about. Just figuring out like this label says this hand sanitizer has 70% ethanol. Well, we tested it and it did have 70% ethanol in it. It was just basically a test to see if the company making it is honest and telling the truth.
Oh yeah.
But yeah, it was all good results. All the labels were truthful.
Well, that's good.
Yeah.
Well, thank you for the presentation.
All right. No
All
problem.
right, thank you.
No problem.
Sure.
Hello?
Hello, good afternoon.
Good afternoon.
Okay, would you like to see what this poster is about?
Yes, please.
Okay. Okay, are you able to see this?
I am.
Okay. Well, this project is all about gas chromatography, and we use gas chromatography to figure out how much alcohol is in different hand sanitizer samples. So in this study, we used Headspace gas chromatography to figure out the percent ethanol, and we wanted to figure out if the percent ethanol stated on the label was accurate. So we used methanol and ethanol isotopes. We used methanol D4 and we used ethanol D6, and those are both isotopes of the regular methanol and ethanol. But the regular, all of the ethanol and the methanol and all the other alcohols in the regular hand sanitizer, they all contain the regular alcohols. So we used a Headspace sampler, and in the Headspace sampler, we had to use 20 milliliter glass vials. And in each glass vial, we added methanol D4, ethanol D6, the hand sanitizer, just one hand sanitizer sample. And we filled up the rest with water up to 5 milliliters. And in this middle part right here, this is methanol, and the blue line is the ion for the regular methanol, and the red peak is the ion for the methanol isotope, or methanol D4. And this one is ethanol. The blue line is regular ethanol, and the red line is ethanol D6 isotope. And this is a output chromatogram for just a test, and we made a mixture of 4 alcohols: methanol, ethanol, isopropanol, and N-propanol. And the results showed that everything did separate. So everything's labeled. Number 2 is methanol, number 3 is ethanol, number 4 is isopropanol, and 5 is N-propanol. And the area of each peak is directly related to how much of that particular alcohol is in the sample. So if a peak has a larger area, then that means there's more of that alcohol in the sample. So we wanted to test how much of a particular alcohol was in like 4 different hand sanitizer products. So over here we tested 1, 2, 3, 4, and we did confirm that all the labels were accurate. Ethanol was the main ingredient in 3 of the hand sanitizers, number 1, 3, and 4, and in hand sanitizer number 2. The label stated that ethanol was not present. Instead of ethanol, they used benzalkonium chloride, and that did not show up in the results. But although it stated no ethanol was in the hand sanitizer, we still found 0.8% ethanol in the hand sanitizer. So the label was mostly true, but we're not sure how that small amount of ethanol entered the sample. So maybe it was either done by the factory, or maybe it was either done by us, but we think it was done by the factory. Do you have any questions you would like to ask me about this?
Yes. So if you're trying to determine if the amount of alcohol is as stated on the as it's stated on the hand sanitizer,
Correct.
does this mean that? Okay. Do you remember like when COVID was first starting out and they said we need to be using hand sanitizer with a 60% concentration?
What did you say? I'm sorry, I didn't hear you.
Sorry. Do you remember when COVID was first starting out and they said we had to sanitize our hands with a sanitizer that had 60% alcohol in it?
Yes, yes.
Okay, so does this mean that we're not that not all of the hand sanitizers that we are using have the concentration that stated, that we could be like putting ourselves in danger even though we're using hand sanitizer?
Um, well, it depends on the brand, because these were all different hand sanitizers made by different companies, and for hand sanitizer to be effective, it has to be, I think, at least like 60 or 70% ethanol. And if it's too low, it will not be effective. And if it's too high, like if it's like 100% ethanol, it will also not be effective, because there has to be a certain amount of water for the ethanol to be effective. So that's why that's why no companies add 100% ethanol, because it wouldn't work without water. It has to have a certain amount of water. So the whole point of the study was to test if all the hand sanitizer labels were accurate, and if the companies were making accurate claims on how much ethanol was being added in their hand sanitizer products. So, but we also wanted to figure out if there was any other alcohol like methanol or isopropanol or n-propanol. So that was another very interesting thing we found. They all contained about 0.4% methanol, and that's a more toxic alcohol. So it would be ideal if there was no methanol in in the hand sanitizer, but all the labels were true though. But yeah, I think the best type of hand sanitizer is the ethanol one, and I think it was shown to be more effective than the non-ethanol one. I mean, as far as reducing the amount of germs.
Is it dangerous to have, okay, I know you said that having like 100% ethanol in hand sanitizer doesn't really work. Can the same also be applied for methanol?
Yes, methanol is a very, very toxic alcohol. I read that only like if a person ingests only 10 milliliters of methanol, then that has been known to cause blindness. So it only takes a very small amount of methanol to cause harm. So be very careful with methanol, and also with like the vapors too. Like be careful to not inhale methanol vapors or any alcohol vapors, but ethanol is not as toxic as methanol. I think methanol is one of the most toxic alcohols, so that's something you really got to be aware of. And it really shouldn't be in any hand sanitizer for our hands, because if we rub it on our hands, that methanol is going to be absorbed through our skin, and that's really not good for us. So ideally, there really should be no methanol in hand sanitizer.
Got you. Those are all my questions. Thank you.
Okay, no problem. Does anybody else have any questions?
So what can be used instead of methanol?
I'm sorry, I didn't hear you.
I said, what could be used instead of methanol or ethanol? Besides hand sanitizers?
Instead of ethanol or
Yes.
methanol? Oh, well, the other product that I'm aware of is instead of ethanol, I heard companies are using something called benzalkonium chloride, and that's used in hand sanitizers without ethanol. And that was the case for hand sanitizer number 2. That was one that had no alcohol smell. It wasn't strong, It was a it was a green hand sanitizer, and it had benzalkonium chloride as the active ingredient in place of ethanol. And this is what we found. So yeah, basically it does not have any ethanol. It's really supposed to have no alcohol really, but for some reason it showed up. It had 0.42% methanol and 0.8% ethanol. But that could either be added by the factory or like a very small error by us, but we think it's by the factory.
Can you disclose any of these brands you used, or you can't do that?
Oh, I'm sorry, I didn't hear you.
Can you disclose any of the brands you used to
Oh,
test your
Okay, the brands, I'm not aware of the particular brands, but I do know that one of the hand sanitizers we obtained from the one in the school, like we obtained a sample from one of the hand sanitizer dispensers in the school, but I don't remember what brand that was. And the other one, um, I'm not aware of any other brand names, but I think they were just common brands like Purell was one.
All right, thank you, man.
All right, no problem. Good afternoon. Does anybody have any questions?
I just got here, so I
Okay.
don't know. Yeah, what is your study about?
Okay. This study is about figuring out how much alcohol is in hand sanitizer samples. So we use gas chromatography to test 4 different hand sanitizer samples to see how much alcohol, if any, was present in each sample. So to prepare the samples, we used methanol, ethanol, the methanol isotope, which is called methanol D4. We used the ethanol isotope, which is called ethanol D6. And we placed the isotopes, a small amount of the hand sanitizer, and water in a 20 milliliter glass vial. And we placed it in the Headspace Sampler. And
Can I ask a quick question?
What?
Can I ask a quick question?
Yes, yes.
I'm not sure which one, but is ethanol or methanol, is that what's the same like chemical that's in gasoline?
I heard that, yes, they do add ethanol and methanol in gas, yes.
Yeah, well, yeah, the name seemed familiar, so I
Yeah,
wanted to see
yes.
if it was true. You could continue. I'm so sorry for
Oh, no
interrupting.
problem. It's fine if you ask me any questions at any time.
Okay, so you were saying that you isolated them.
Right, right. We decided to use a Headspace sampler to take a sample. So what the Headspace sampler does is it takes a sample of just the vapor of the hand sanitizer. So you know how like the hand sanitizers have a very strong smell?
Yeah,
Well, a Headspace sampler just takes the vapor of the hand sanitizer. It does not take the liquid.
right.
And we decided to use the Headspace sampling because if we tested the actual hand sanitizer directly, that has a lot of sticky chemicals in it. You know how it has glycerin and other sticky substances, and that might damage the main GC instrument. So that's why we decided to just use the vapor Headspace sampler.
Okay.
So this figure 1 is a separated alcohol mixture. It was just a test to see how well the instrument can function. And we mixed methanol, ethanol, isopropanol, and N-propanol all in one vial. And then we placed it in the machine. And then the machine separated all all 4 alcohols, and this is what it looked like when it's separated. It all showed up as a different peak. So that's how we know that methanol is right here, ethanol, isopropanol, and N-propanol.
Yeah, because I've noticed, well, I mean, ever since COVID, I did notice that the smell changed in hand sanitizers. And
Right.
like some smelled like literal liquor and others just smelled like just alcohol, like regular, like rubbing alcohol. But there were others that smelled like hard liquor. And I was just like, why does it smell like that? So that's interesting to know. Which you did say that when I came in, you were mentioning that you used like 4, well, it says 5. What 5 brands did you use? Did you use Germex by any chance?
I'm not aware of the brands at this moment. I don't remember any of the brands.
That's okay. Well, what were your findings, of course? Like the 4 and 5 are pretty close together with the level of, alcohol, right?
Right. So the results showed that hand sanitizer number 1, 3, and 4, they were shown to contain close to the percent ethanol that was claimed on the label. And the results also showed that all 4 hand sanitizers contained about 0.4% methanol. And what's interesting is that was not advertised on the label.
Interesting.
And hand sanitizer number 2 was claimed to have 0% ethanol. The active ingredient was benzalkonium chloride, but we did find it did have a very small amount of ethanol of 0.8%.
Okay. What does that personally tell you about the businesses who are like not putting the full information on the labels, allowing people to use it?
Well, all the companies are supposed to state what goes in the products. And this is especially true for methanol because that's the more toxic alcohol.
Right.
So it's surprising that they didn't list methanol. But I've heard now that people are starting to be more aware of methanol in hand sanitizers. And I think companies now are not adding any methanol in hand sanitizers. They're just making sure it's just ethanol only.
Well, that's interesting because I didn't even know.
Yeah.
Yeah. Well, I'll definitely keep a lookout. Thank you so much.
Okay.
Hey,
Hello, Dr. Trufan.
how are you doing?
Pretty good.
Would you mind sharing some of your work?
Oh, sure. Okay, so we decided to use gas chromatography to figure out how much alcohol is in different hand sanitizer samples. So in this study, we decided to use Headspace gas chromatography to figure out the percent ethanol and to figure out if the label claim on each bottle was accurate. We also wanted to figure out any trace amounts of other alcohols, such as methanol. So each sample was prepared by mixing methanol D4, ethanol D6, the particular hand sanitizer sample, and water. And we placed it in a 20 milliliter Headspace vial and sealed it with a crimp top. We decided to use a Headspace sampler because hand sanitizer contains glycerin and other sticky substances, and this might damage the separation column inside the GC. So in the middle part of the poster, we placed a chromatogram, and figure 1 is a separation of an alcohol mixture of methanol, ethanol, isopropanol, and N-propanol. And we just wanted to show that all the method conditions, like the temperature, like the oven, the GC oven, and all the other settings of the GC and the Headspace sampler, and the column, they all do result in a successful separation. And in figure 2, it shows that the 31 ion in blue is methanol D0, or a regular methanol, and the 45 ion, this one in blue, is regular ethanol, and the small red peaks under the blue peaks are the isotopes, which are methanol D4, which is represented by a 35 ion, and ethanol D6, which is a 51 ion. And the internal standard alcohol and the alcohol in the hand sanitizer products were shown to produce 2 separate distinct peaks. And we had to be careful not to add too much of the internal standard, because the red peak was, I think our first test, the red peak was too high and the calculations would not work. So the first step to calculate the unknown ethanol concentration is to multiply the amount of internal standard added, which in this case was 0.02 milliliters. We multiply that by the internal standard density, which was 0.789 grams per milliliter, and then the molar mass reciprocal of the internal standard, which is 1 mole over 52 grams. Then during the second step, the area of the alcohol in the hand sanitizer, which in this case could just be ethanol, we divided that area by the area of the internal standard. So it's like the area of the blue peak divided by the area of the red peak. And then this fraction is multiplied by the result from step 1. And then in the third step, the amount of alcohol in the hand sanitizer, which was assumed to be 0.4 milliliters, is multiplied by its density, which was ethanol, which is 0.789 grams per milliliter. And this number is divided by its molar mass, which was 46 grams per mole. And the number obtained from the second calculation step was divided by the number from the third calculation step. And this calculation resulted in a decimal number that was multiplied by 100 to obtain the percent ethanol present in a sample. And that is how we got these numbers in the chart. So we found that hand sanitizer number 1, 3, and 4, they contained the percent ethanol that was accurately described on the label. And they also showed that all 4 hand sanitizers contained 0.4% methanol, which was not advertised on the label. And hand sanitizer 2 was claimed to have 0% ethanol. Instead of ethanol, it used benzalkonium chloride, but we did find that it contained only 0.8% ethanol. We did find it did contain a very small amount of ethanol. Do you have any questions you would like to ask?
Yeah, my question would be related to, why did you use methanol and ethanol, their deuterated forms, to make your sample?
Because in this column, we used a packed column instead of a capillary column. And with this column, the ethanol D6 and methanol D4 appeared at the same exact retention time as the regular versions, the non-isotopes. So like methanol D4 appeared at the exact same retention time as methanol D0.
Well, the reason why I'm asking is because both the deuterated methanol and the deuterated ethanol contain about 5% non-deuterated solvent.
Mm-hmm.
And so I'm wondering if in your sample, you're not detecting the traces from the deuterated solvent and actually determining the traces from the sanitizer.
Maybe.
That's I'm just putting it out there when,
Okay,
when
okay.
you're mixing it, because you're using a very small amount of sanitizer and you have very small percentages. So in relationship to that, those traces may come from your deuterated solvent. And the only way to kind of take that out of the equation is to switch to a different solvent, a different deuterated solvent, and maybe, just maybe, if you were right and the methanol and ethanol traces are from the hand sanitizer, then your percentages shouldn't change. But if they are coming from the deuterated solvent, those percentages will.
Okay.
So I'm just wondering, what was the rationale behind using both of those?
It was just to make it was primarily to make a comparison, just for a comparison, and the fact that on this column they had the same retention time, and by adding different amounts, by adding only 20 microliters of each isotope, then we were able to make a comparison of the areas, and that's how we use the areas, the difference in areas for the calculation.
All right, thank you so much.
Thank you. Good afternoon. Do you have any questions?
Hi, good afternoon. I'm so sorry. I just came in, so I missed most of it. If you want, I can read off the poster, or if you want to give a summary, it's up to you.
Okay. Well, basically, the whole project was about figuring out how much how much alcohol was in different hand sanitizer products. So our goal was to figure out if the claim on the label was true. And we did this by using gas chromatography. So we first prepared the samples by mixing methanol D4, which is an isotope, ethanol D6, which is the isotope of ethanol, and the specific hand sanitizer sample, and add water up to 5 milliliters. So we mixed those 4 samples in one 20 milliliter Headspace vial, and then we placed that vial in a Headspace Sampler. And what the Headspace Sampler is designed to do is just take the sample above the liquid part. So the headspace is just the part above the liquid in the vial. And we chose to sample just the vapor only because we didn't want to sample the actual hand sanitizer, because the hand sanitizer is sticky and it has glycerin in it, and we thought that might ruin the machine testing the hand sanitizer. So after we tested each compound, we also made a mixture of all 4 alcohols, which is shown in figure 1. And then figure 1 is the result of the separation of the 4 alcohol mixture. So peak number 2 is methanol, 3 is ethanol, 4 is isopropanol, and 5 is N-propanol. So the whole point of figure 1 was to show that all the settings on the machine were properly working. And the machine does separate all 4 alcohols. So then, to get very specific, we focused on ethanol and methanol. So these figure 2 is a comparison of regular ethanol or regular methanol, which is shown in blue. The blue peaks are regular ethanol and methanol, and the red peaks are the internal standard ethanol and the internal standard methanol. And this shows that the internal standard and the regular version of the alcohol, they have the same retention time. And since they were added in a much smaller amount, then the peak is much lower than the regular version in blue. So we used that difference in the red and the blue to figure out how much exact methanol or ethanol or any other alcohol is present in a hand sanitizer sample. And we just repeated the same process over and over again for like four samples. So overall, the outcome of the experiment showed that all of the labels on the hand sanitizer products were shown to be true, and that hand sanitizer number 1, 3, and 4 were shown to contain a percent ethanol that was claimed on the label. And it also showed that hand sanitizer number 2, it contained the smallest amount of ethanol, but actually it was claimed to contain 0% ethanol. The active ingredient for hand sanitizer number 2 was benzalkonium chloride, and that's used in place of ethanol because it won't have like a very strong smell. That hand sanitizer did not have a strong smell. So ethanol is the main ingredient in hand sanitizer 1, 3, and 4, and hand sanitizer number 2, it was benzalkonium chloride. And it was found to contain a very small amount of ethanol, although it was claimed to contain 0% ethanol.
Thank you for that. That was actually really interesting. So out of like all 4 hand sanitizers, would you like recommend using like hand sanitizer 4 or 1, or which one would you recommend?
Well, it depends on like like all the hand sanitizers that contain ethanol, they will always have that strong alcohol smell. But if a hand sanitizer does not contain any alcohol, then it will not have that very strong alcohol smell. So if the strong alcohol smell is something that you don't want to smell, then I would recommend the one with benzalkonium chloride, because that was shown to also reduce the amount of germs on your hands. But the ethanol, I heard, is stronger than the benzalkonium chloride, but it has that strong smell. So if you're more worried about reducing the amount of germs on your hands, then I would go with the ethanol-based hand sanitizer. But if you're more worried about the smell, then then I would go with the benzalkonium chloride based hand sanitizer.
Okay, thank you. Thank you. Once again, you did a really, really amazing job with your presentation. And thank you for informing me about this. I think that your research is pretty cool. And yeah, thank you.
Thank you. No problem. Thank you.
Hi, Austin.
Hello, Professor.
Hey, how are you?
Pretty good.
Yeah. I had a class in the morning, so I just finished my class and I came here just now. So how is going?
Pretty good. Pretty
Okay.
good.
Few people came.
Yes, yes.
Okay. So good. So how is this work? So you just display this on and someone comes and then start talking, or?
Yes, I wrote a script about what I'm going to say. I wrote a script that describes the whole process from start to finish, like what the ions mean, how the samples were prepared, and how the percentages were calculated, and what the results mean.
Okay, great. Okay. So is it a recording or it's a?
Yes, we were told to record this. Yes.
Record this one. Okay, great. Okay, great. Okay, then good luck. I will just need to go to some other one. Then I will. So how long will you be here? Till 2?
Till about 2:05 until it's over. Yes, sir.
Okay. Okay, then thank you.
Yes, sir. Thank you.
Bye-bye.
Hello. Good afternoon. Are you able to hear me?
I'm sorry. Maybe I made a mistake.
Are you able to hear me?
Yes, I can hear you.
Okay.
I'm so sorry.
You
Maybe
have.
I made a mistake.
Oh.
I'm not sure if it's my turn. My turn should be the group 2.
Do you have any questions you would like to ask, or would you like me to explain this project? Hello, good afternoon. Good afternoon. Are you able to hear me? Okay. I'm gonna share my screen. If you have any questions, you can just let me know, or if you want me to explain something, I'll be happy to explain something. But I don't think I can see the chat. I don't think I can see the chat when I'm screen sharing. Let me see. Yeah, okay. Yeah. Okay, so if you have any questions, just let me know. I'll be happy to answer them. If you have any questions, I could also answer them in the chat too. Okay. Headspace. Okay. The headspace means, it basically just means like the air above a liquid. That's what headspace means. Like for this experiment, headspace refers to the air above a liquid in a sealed vial. Like we placed methanol D4, ethanol D6, which are both isotopes of the regular alcohol. And then we placed the hand sanitizer sample, just one, and then water, all up to like 5 milliliters. So in this glass vial, this, like, it was like a small glass vial cylinder, and it was only like 1/4 full, only up to like 5 milliliters. And the headspace is the all the area above that 5 milliliters of liquid. So the headspace basically just refers to the gas above a liquid, not the liquid, but the area above the gas above the liquid. Pictures. This is the only photo I currently have right now. I did not take any pictures of the experiment. The only thing that we did do is we just exported these two chromatograms, and these were created in Excel. So these two chromatograms are exported, and we placed all the data into Excel, and these charts were created with Excel. But on the output of the machine, it produced charts that were just very identical to these, although not exactly the same. It's the same data, but I didn't take any actual photos of the samples or anything.